Welcome back, Chemistry 30. This is a Le Chatelier assignment at the end of EQ 1.6. You can access this handout. I'll just kind of go through it, what I'm looking for, and hopefully you should be able to do it. So what does Le Chatelier's principle say? What are three kinds of stresses? You'll find that all in EQ 1.6. Now this question is kind of a neat one. It says here, for each reaction below, state the direction left or right in which the equilibrium will shift when the indicated substance is added. Okay, so over here it's kind of difficult to read, it's kind of thick, but make a teeter-totter for a lot of these stresses, and you can see which way the shift needs to happen. And then identify another way that you could cause it to shift the same way. Hint, there may be more than one possibility. So for this first one, let's say we have the formation of ammonia. Nitrogen plus hydrogen yields ammonia. And let's say the stress is NH3 added. So if you think of the teeter-totter, NH3, it's on the right-hand side, it's a product. So it'd be like adding something to the right-hand side of a teeter-totter. Of course, it would get heavier here. So to make things in balance again, it would have to shift to the left. So it would use up the X, so the stress is increased NH3. The response would be to use up the NH3, and then shift to the left by making more reactants and using up the products. So what else could you have done to make it shift to the left? Well, if we want the teeter-totter to look like this, we could have removed some reactants. So over here I put also reducing nitrogen would have done this. So removing N2, removing H2. So you can make the teeter-totter look like this by adding stuff on the right or taking stuff off the left. Okay, so that's what you have to do for that question. There's a word, fill in the blank here, and at the end here, a matching scenario here. Of course, here they talk about volume increase. Remember, volume increase is the same thing as pressure decrease. So if you want to change all these volume stresses into pressure scenarios, you can. It's just the opposite. Volume increase is the same thing as pressure decrease. Volume decrease is the same thing as pressure increase, etc. And of course, with pressure volume, you need to count the number of gases here. So if we look here, there's one CO. This is a solid, so it doesn't count. So there's only one gas molecule on the left. Over here, we have one gas molecule in a solid, so one gas molecule on the right. So we have 1 and 1. So if you change the pressure, guess what? Nothing happens. There'll be no change because there are equal numbers of gases on each side. So yeah, so it could shift to the right, shift to the left, or as in this case, no change. So please be aware of that. All right, so go ahead and do that, and you should be okay with that. We'll see you again.